Welcome to this physics problem-solving video. Today we'll tackle a classic kinematics problem involving two balls moving in opposite directions. Let's read the problem. A ball is dropped from the top of a tower 80 feet high at the same instant that a second ball is thrown upward from the ground with an initial velocity of 40 feet per second. When and where do they pass? And with what relative velocity? This is a great example of solving one-dimensional motion problems with constant acceleration. Let's first understand the problem by drawing a diagram. For this problem, let's establish our coordinate system and variables. Since we're dealing with vertical motion, I'll place the origin at the ground and define the upward direction as positive. Let's define ball 1 as the ball dropped from the tower top, and ball 2 as the ball thrown upward from the ground. The initial conditions are, for ball 1, initial position y sub 01 equals 80 feet. And initial velocity v sub 01 equals 0. For ball 2, initial position y sub 02 equals 0 feet, and initial velocity v sub 02 equals 40 feet per second. Both balls are affected by gravity, which gives a downward acceleration of 32.2 feet per second squared. That means the acceleration value equals negative 32.2 feet per second squared when using our coordinate system. To solve this problem, we need to first, find the position equations for both balls as functions of time. Second, determine when the two positions are equal to find the meeting time. Third, calculate the positions at that time to find where they meet. And finally, compute their velocities at the meeting time to determine their relative velocity. Now, let's derive the position equations for both balls. For one-dimensional motion under constant acceleration, the position is given by the equation y equals y sub 0 plus v sub 0 times t plus 1/2 at squared. For ball 1, the initial position y sub 01 is 80 feet. The initial velocity v sub 01 is 0 feet per second. The acceleration is negative 32.2 feet per second squared. Substituting these values, we get y1 of t equals 80 plus 0 times t plus 1/2 times negative 32.2 times t squared. Simplifying, y1 of t equals 80 minus 16.1 t squared. Similarly for ball 2, the initial position y sub 02 is 0 feet. The initial velocity v sub 02 is 40 feet per second. The acceleration is the same, negative 32.2 feet per second squared. Substituting these values, we get y2 of t equals 0 plus 40 times t plus 1/2 times negative 32.2 times t squared. Simplifying, y2 of t equals 40t minus 16.1 t squared. Let's visualize the paths of both balls over time. Now that we have both position equations, we can find when the balls meet by setting them equal to each other. Setting y1 of t equal to y2 of t gives us 80 minus 16.1 t squared equals 40t minus 16.1 t squared. The t squared terms cancel out, leaving us with 80 equals 40t. Solving for t, we get t equals 80 divided by 40, which equals 2 seconds. We can verify this result makes sense. Ball 1 starts at 80 feet and falls due to gravity. Ball 2 starts at ground level with upward velocity, reaches maximum height, then falls after 2 seconds. Both balls will meet somewhere in between now. Let's find where they meet by plugging t equals 2 seconds into either position equation. Using ball 1's equation, y1 of 2 equals 80 minus 16.1 times 2 squared equals 80 minus 16.1 times 4 equals 80 minus 64.4 equals 15.6 feet from the ground. This means the balls meet 15.6 feet from the ground, or equivalently 64.4 feet from the top of the tower. Now that we know when and where the balls meet, let's find their velocities at the meeting time to determine their relative velocity. The velocity equation for motion under constant acceleration is v equals v sub 0 plus a times t. For ball 1, the initial velocity v sub 01 is 0 feet per second. The acceleration is negative 32.2 feet per second squared. The time t is 2 seconds. So v1 at t equals 2 is v1 equals 0 plus negative 32.2 times 2 equals negative 64.4 feet per second. The negative sign indicates ball 1 is moving downward. For ball 2, the initial velocity v sub 02 is 40 feet per second. The acceleration is negative 32.2 feet per second squared. The time t is 2 seconds. So V2 at t equals 2 is V2 equals 40 plus negative 32.2 times 2 equals 40 minus 64.4 equals negative 24.4 feet per second. The negative sign indicates ball 2 is also moving downward at the meeting point. The relative velocity is the difference between these velocities. V relative equals V1 minus V2 equals negative 64.4 minus negative 24.4 equals negative 40 feet per second. The magnitude of the relative velocity is 40 feet per second. This means ball 1 is moving 40 feet per second faster than ball 2 at their meeting point. In this problem, both balls are moving downward when they meet. Ball 1 has been accelerating from rest for 2 seconds, while ball 2 has passed its maximum height and is on its way down, but hasn't been falling as long. To summarize, the balls meet after 2 seconds. They pass at a height of 15.6 feet from the ground. Their relative velocity is 40 feet per second. This problem showcases several key concepts in kinematics. First, when analyzing multiple objects, we apply the same physics equations to each object independently. Second, to find intersection points, we set the position equations equal to each other. Third, relative velocity is simply the difference between the individual velocities at the meeting point. The general approach we use can be applied to many similar problems. 1. Establish a coordinate system and define variables. 2. Write equations of motion for each object. 3. Find when objects meet by setting positions. 4. Determine velocities at the meeting time. Thank you for watching this video explanation. I hope this helps you understand how to solve kinematics problems involving multiple objects.